Welcome
Welcome
everybody.
everybody.
Tonight is the 21st of February. This is Dallas Personal Robotics Group. Robot Builders Night Virtual. We're going to do the usual thing and go around the table and talk mainly about roboty things. And talk about progress on projects and raise some questions, and then have an open mic meeting. So far we have in queue Ray, then Mike, then myself, and then open mic night. So Ray, what do you got?
Okay, it's one of the things that I ordered finally. Oh, probably should go to presentation mode, shouldn't I? Ooh. Entire screen. Okay. Share. Okay. Can you see this page here with a board to one side? Okay. So this is what I got. It's supposed to be a, 6 to 60 volt, 400 watt brushless DC 3-phase, motor driver. And you can get them either with or without the connection to the Hall effect sensors. And so this one has the Hall effect sensor connection. And apparently, if you know the position of the rotor, through these Hall effect signals, you can commutate more accurately so that, you won't get like on startup, if you don't actually know where the rotor is positioned, and you energize the wrong phase, it may, go in the wrong direction. So that helps with that, and with, variable speed to know when to commutate the switch to the next two of the three phases, either, AB, BC, or AC, depending on which direction you're going in. So this one is, you can actually drive it with just an analog signal. And that's if I get too close to this, it magnifies it. But 0 to 5 volts, so you can use, a filtered PWM output. Or you can go into here, into this input. The P signal is the PWM input, or signal input is what they're calling it. This also has like a tachometer, or they're calling it an SC speed pulse output. And it looks like it's the combination of the three Hall effect signals. So it's like, the A, B, and C Hall effect outputs, overlap each other. And then this seems like, I don't know, maybe an exclusive ORing of that, where you're getting, 6 edges per cycle, 6 pulses per cycle, versus just, 3 for the outputs of the Hall A, B, or C. One of the things I couldn't, it's difficult to say, there's not really any documentation on these. So you basically input a PWM signal, and it tries to get the motor rotating at whatever speed is indicated by the PWM signal. I don't know if there's any feedback on the board. I don't think there is. So I think it's just a driver. It'll, since it's got Hall inputs, or connections to the Hall effects in the motor, like I said, that helps with synchronization and commutation. But I don't think it has anything to do with actual feedback, like increasing the drive. So I think you still has to sense how fast it's rotating, and I'm going to go back to this. You can pin me if you want, or pin my image. Anyway, so this is one of the boards. I've hooked it up to. This was a hoverboard motor, and here's one of them here. So this shaft is, it's got a big flat on it there. I don't know if you can see it in the reflection, but that's held down by a bracket. There's 4 screws that hold this in position, and the wheel actually rotates around that shaft. So the shaft doesn't move because there's phase wires and Hall effect signal wires. There's the 3-phase wires and the Hall effect signal wires there. This one, most of them have 5 wires. It's VCC, ground, and the 3 Hall effect signals. This one also has what looks like a TAC output. It's kind of weird. It's not a 0 to 5 volt thing. I think it required some analog circuitry to basically to use it. Anyway, so I've hooked this up, and oh yeah, that was the other thing. A lot of the other, and this was a Tanner special, but it not only does it have the little image came up on the thing. The Hall effect sensors, which are these 3 wires coming out here, but it also has a shaft encoder on it, and these usually have pretty high resolution. Anyway, so actually no, this one was not a Tanner electronic one, but it's one that I've been wanting to power up and try. I have 2 others that are smaller than this that were from Tanner's, and so now that I've got this driver, it'll be a lot easier to power them. And I think I can show this without disrupting too much stuff here. Do that. Turn on that. Anyway, so there is the wheel rotating on the edge of it. You can barely see it. There it is. I don't know if you can see that. Can you see it?
Oh yeah. Oh yeah.
Changing colors, maybe. Anyway, so that's just speeding up and to a max speed and then slowing down. And anyway, so it does, it does work pretty good. It's pretty smooth. And apparently the brushless DCs versus just a straight DC motor, I think the torque can be constant with speed. So in a DC motor, and I think from what I understood, it's not linear, but it will increase with speed. So you can get just better drive characteristics out of it. At a slower speed, you can still have the same amount of torque as you would with, a DC motor running at a higher speed. So the little motors are pretty powerful. They ran on a 6S 2P battery that was in the hoverboard. So it's, it can push a 200-pound person around. So powerful enough to do that. And I think they said it would last up to 6 miles on flat ground. Of course, they didn't say how heavy of a person it would be pulling. But so anyway, I've always wanted to, just kind of play around with the 3-phase brushless motors. And those drivers were cheap, I think. What was it? Oh, I got to do the sharing thing again.
Yeah, it looks like that might be pretty good for a two-wheel differential robot for outside.
Yeah. Yep. Yeah. I was a little concerned. The wheels are kind of smooth. You do get pretty good clearance because the shaft, there's probably 3 inches above the shaft. But yeah, this was, I think that's about what I paid for it. I got 2 of them, and the shipping was a little bit higher than this, but I think it came out to less than $10 each. And they seem to get pretty good reviews. 4.6 out of 89. The documentation is horrible. It's like, I don't know. It's like, what were you trying to say here? Because, you read it and it's like, okay, that could mean several different things. As far as like the state of, like stop, is it active low or is it active high? And it's okay. So stop when enabled, both forward and reverse and stop are low level active. Well, the one signal is direction. It's either forward or reverse. So, it can't be, they both can't be, active low. One of them has to be active high. And the brake input, I don't know if I would actually do this or not, because I think it goes into the signal of the circuit, which I can barely read what the numbers are on. But it says you can from 25 volts to 5 volts. So I think that was supposed to mean 2.5 to 5 volts. I don't, I think if you stuck in 25 volts, you'd blow up half the board or something. So, documentation on the thing is really lacking. There's nothing else in, you can scroll down and this basically, says the same kind of things. It's like, okay, it's just a bunch of gibberish, but you can figure it out without, too much effort.
Question, why didn't you use the drivers from the hoverboard?
Oh, yeah, they had nice bridge drivers on it, but each side has a processor, and it's somebody, here's one of the driver boards here. They're pretty close. There's just some missing circuitry on one has some battery charging components that this is not the side that does, but it's got the 6 transistors that make up the the 3 half bridges, and it looked like a really nice setup, but there's I couldn't find any documentation. It looks like the older hoverboards had a totally different printed circuit board inside of them. I haven't seen anybody that's hacked this. There are a couple places, it says one says remote. It's got like 4 signal lines to them. So, and one of them I know is 2 of them 3.3 volts and ground. The other ones might be TX and RX. They could be, I squared C, SDA, SCL. Don't know. And there's probably like a list of commands that you could give it from that interface, but I haven't seen any documentation anywhere on it. So this actually has apparently a gyroscope on it, and it senses like the 2 halves of the hoverboard. It's kind of like on a pivot in the center, and if it senses that your foot is like pointing down a little bit, I guess that's an indication that you want to move forward. And if you're level ground, no movement, and if you tilt your feet back a little bit, that's backward motion. So, and I've seen where people put 2 little levers on a platform that are kind of like hinged, so they can push the 2 different sides together, and they actually put out a place to put your feet so you can sit on the hoverboard and you know, steer it around that way and not break your neck, I guess. So it seems like a lot of people my age, I've seen tons of videos of, you know, people scooting around on them, and, you know, almost like they have levers almost like a skid steer, and they're just tilting the two different sides, you know, to either go straight or turn or back up or whatever. So, but I'm not going to get on the thing because, you know, that'd be a disaster. Oh,
You mean you don't want to break your neck?
Yeah. Not ready to break my hip yet. Yeah, the LEDs, they're fixed position in the hub, and this pattern rolls around when the wheel, or turns when the wheel turns. So it's just like letting different LEDs, stationary LEDs, let the light shine through. So different color LEDs. So it looks like it's, you know, it's spinning, but the LEDs aren't. So, but yeah, they're, you know, as far as what it took to make the thing, this bracket is pretty heavy duty. This is what holds the, you know, it's just like a stamped piece of steel, and it's, you know, it's got the, and this, you know, the flat on that shaft rests against this, and it's just screwed in with 4 screws. So that's a nice piece that I could reuse if I ever decide to stick it on a robot. But so it was kind of fun. I think I paid $6.99 for the hoverboard and at the Goodwill, and the battery isn't any good anymore. It's you know, won't charge back up, but just for the wheels, I mean, you know, that was pretty good, I thought. So, anyway, so that's all I had. That's my little foray into brushless DC motors.
Well, that's pretty cool.
So you got,
yeah, it is. Got some progress.
Yep.
Okay, I guess I'm next, correct?
Yeah. What do you got, Mike?
Well, I got a question. It's about the 6 can.
All right.
And I have an idea, and I want to run it by you guys and see if you shoot me down or you give me the go ahead. I want to do the man, I just had a senior moment. I want to go ahead and on the 6 can, I want to do the drive-by technique. And I want to do, just for the challenge, I want to do ultrasonic sensors instead of a camera. But here I want to show you this. My idea is to have these 2 different sensors. I don't know how far away to have them. Y'all see those just fine?
Yeah.
Y'all see those sensors?
Yeah.
Mm-hmm.
And once my deal is when you drive by a can, I'll have them on both sides of the car. This, of course, this will be on the car. And when you drive by the can, when one set changes state, that's when it triggers the robot to stop and turn and go pick the can up. I was wanting to know what you guys thought about that idea. Because what it'll do is these will relatively, I'll have a threshold that these will stay in. All they'll see is the wall of as it drives by, all they'll see is the wall of the arena, or whatever you want to call it. And when one of them changes state, when it goes by a can and changes, then when the 2 aren't the same reading, then it triggers the car to stop and turn and go pick it up and then come back. What is y'all's opinion of that idea?
I think that's what James Leroy used on his, but he hasn't been to any of the meetings in some time. And David Anderson used kind of a similar approach. He had two they're really large sonars.
I've seen them on his robot.
Yeah. And I think he has them angled, they're not perfectly, well, if you're looking down on the top of the thing, he has them angled out a little bit. And I think kind of the idea was that if you got in between the can, or the can got in between the two ultrasonic, beams, that he could tell, just by like turning slightly left or right, that,
You were in
there
the
was a
center.
can between the two.
Well, see, this would be like on the side of the car, of the robot, and then maybe have two in front and then two on the other side of the robot, and it would be reading all them as you go straight through the competition arena. And
So are you planning on like trying to be as close to the middle as you can, right down the center?
I'm going to try to drive down the middle.
Okay.
And then if I see a can with this setup, like I was describing, then it'll turn, go get the can, go back to the center, and then go head out to the end of the enclosure. Is that a bad idea? What I'm thinking on how to do that, or as far as using these ultrasonic sensors? Instead of trying to
do it,
huh? You think you'd do it?
The only situation you might run into is can might be right in the center.
Yeah, that's why that crossed my mind. So that's why I was saying if I could put two sensors in front, and it would see in front of me if there's a can right in the middle. And then do what you said to do, like and then do what you said to do, kind of read between the two, or even have the claws big enough to just scoop it up, as you go into it and then close on it. I don't know.
Yeah.
Is this a bad idea? I mean, I'm looking for opinions here because you guys know this stuff better than I do.
Yeah. I didn't really mess around with ultrasonics that much. I know Doug has quite a bit. Doug Parodies.
Doug. Yeah, that's who I was trying to think his name, Doug's name, and I had a senior moment, but so anyway, that was my idea. I'm going to give it a shot unless you think you guys.
So you're going to have two in the front and two on each side?
Yes.
Yeah.
And then if I go down the middle, it'll read. It'll. If it goes by one, it goes by and goes. I see a can on my right side. It'll turn that way. Go pick it up, and then I'll use odometry to come back to my point. And then keep heading towards the end of the arena.
Hey, Michael, before you get too far, you should experiment on those mounted side by side and see if you get like crosstalk between them, or have interference.
That crossed my mind. I've got my experimental prop right here.
Okay.
So I'm actually going to probably just set this on my table and do what you're saying. That crossed my mind because I could sit these, several inches apart if there's that crosstalk you're talking about. Which I don't know. I've never messed with these like that. But then I'll just kind of move the can, like that. That was so. Yeah. Thanks, Ted. Okay, unless you guys tell me otherwise, I'm gonna try this for the.
Sounds interesting. I mean, you'll have to go. I've never done it, so I can't comment much. But just thinking out of the box, it sounds like you'd have to have some kind of time-based cue, like a FIFO or something, right?
And where you keep
track
track
of the measurements as they come through, and then you'd have to have a way to look at that cue every now and then and decide, well, does the profile mean that there's a can?
Yeah. Now, here's what my thinking is, and if you try to use one sensor per side and read the back and read the side of the competition wall. But you don't ever know that you're right in the middle because your robot might drive off center a little bit, and then it changes. If you got a can right upside the wall or real close to the wall, it might not change good. So I decided I'll just use 2 sensors, and then if one sensor changes state and the other one doesn't, then I know regardless of how close I am to the wall on the side. You follow what I'm getting at?
Yeah.
Mhm.
So that was my thinking.
Yeah, another similar sensor to consider is the those little infrared rangefinders. They're a little more precise in their measurement. The beam doesn't spread out as much.
It doesn't have that angle to it.
Yeah, correct.
I could go that route. I'm just saying, is this concept you think doable or maybe worth trying? I don't want to waste all my time on it.
Mhm.
It seems worth trying.
And I won't be competing against anybody like a guy named Scott or anything like that. I'll just be competing against the challenge.
Come on, Michael. I mean, Ray's proved already it doesn't take much to come in second.
Oh,
There you go.
I would kind of echo Ted's comments about the ultraviolet rangefinders, because the ultrasonics, it's sound, right? So it's not very precise as far as aiming it. It's a very large area, and they're also fairly slow, right? Because you have to wait for the sound to bounce back. And
Yeah.
And like Ted mentioned, you have crosstalk between them. So normally you like initiate the sensor reading, right? So you have to sequence the initialization per sensor and then wait for the echo to come back. So it's fairly slow.
Okay.
So the other thing I would caution you is the velocity of your robot, needs to be in sync with how fast you can read your sensor data, right? Because you may drive past a can because a can's only so big, and you got this sonar cone that's going to be several inches within a couple of feet. I don't know what the actual spread is, but the other thing I would caution you about, or that you would need to deal with, is the edges in the course, right? Just because you're going to try to stay in the middle doesn't necessarily mean you're going to be successful at that, right? So when you go through the goal, even if you pick up a can and you go through the goal, how do you know you went through the goal, right? Because your side sensors are now going to change again, right? So you got to, the fact that you have variance, or a step in a reading, let's call it. In other words, you read the wall and then you read something else, which is much closer to you. That may not necessarily be a can. I mean, a lot of the times it might be. And the other thing, because of the spread of the sonar, if you have 2 cans, right? Because there's 6 cans in this course.
Right.
You may go by 2 cans that one sonar picks up the other one. So how do you determine where the can actually is just because you had some step function in your sonar, right? So these are things that you would need to address, like in software or in the timing, and like I think Ray brought it up, where David, he centers on a can, he puts them between the 2 sonars, so he knows, okay, now I know there's a can, I can center up on it. So there's a couple of things that you have to really address: finding the can, and then centering on the can and collecting the can, and then of course taking it, scoring a goal with it, right? So think all those elements through of how you would do that with just the sonar data would be my recommendation.
And the infrared would probably be a better choice as far as lack of narrowing down the beam.
Right, but you're fighting the complete opposite problem there. Is now instead of looking out here, you're looking through here.
Right.
So it's kind of a give
Well,
and take.
at least this time I do it, it's not a matter of speed or how fast I do it, but a matter of just accomplishing it. So I can slow my robot down because I won't be competing against anybody. Is there a minimum time limit on that?
15-minute limit or something, I think.
15 minutes, I can do that.
2 hours, maybe.
2 hours.
Well,
When people start going home, that's when it's time to quit. Is that what you're saying? I guess.
I think you can do the 2 hours, but you only get one run.
Just depends on how long your battery will run your robot.
Yeah,
Right.
that's true. 2 hours is a long time.
All right. Well, I'm going to go ahead and pursue this. And if you guys can give me like a half a thumbs up or something. So.
Sounds like a good
Hey,
try.
Yeah, it seems worth trying.
It's not a bad idea till you lose to Ray.
Oh, man. I think
it's just a small matter of programming.
Yeah,
There
just
you
a
go.
couple of lines of code.
All right. That's all I got.
All right,
All right, cool.
Well,
Let's see. I've had a few other people join. I'm next in queue technically.
Does
anyone else have some stuff they want to add in the queue after me?
All right.
All right.
I can. I've been working on the new course. I can give an update on that. If you want.
Okay. Cool. I'll cue you in after me, Scott.
All
The
right.
new course? What new course?
Yeah, the new can course.
He's
He's been building one for us. So let's.
Oh, yeah, okay.
Let
me,
Talking about.
Take a detour here, and then Scott, just gather your thoughts, and let's see if I can do this
a
a
different
different
way
way
without
the presentation screwing up.
All
All right, so the first thing I have, which is more closely robot related, window sharing works, screen sharing doesn't. Is that I noticed in the last week that VS Code says the legacy Arduino IDE extension is going to stop working.
Uh-oh.
Yeah, that makes me very sad. I've really come to
I-
rely on it.
I use that new IDE, by itself. And I've loaded up the old one and went back to it. I'm just saying it's got some bugs in it and stuff that you got to like shut it. If you unplug a card, an Arduino and stuff sometimes and plug it back in, it won't recognize it. You got to restart. It's still got bugs in it. The new one does. That's all I got to say.
All right. Has anyone tried this bundled Arduino CLI or?
Nope.
All right. So I'll be
Okay,
forwarding.
so the legacy Arduino IDE, what do you know which rev that is? Is that like 1.18 something?
It's like 1.8 ish. 1.8 ish is the legacy.
Let's figure out what this means. I guess because you're saying that the Arduino supplied IDE has changed, and I forgot about that.
It's at a 2 point stuff. Let's see where it's at today. 2.0.3 is the brand new one, as opposed to 1.8 point stuff.
Okay, maybe I'm overreacting because I've really come to like the way that Arduino extension from Microsoft works. But if it just means that it's going to use a different compiler than the original compiler, then that doesn't bug me at all. If it still has like this nice, it's got this nice set of features basically.
And Carl, the new compiler is faster than the old one, so it's got that going.
Yes, it is.
Well, that's positive.
It's about 3 times faster.
How could they deprecate this? 1.6 million downloads? Huh. All right, they can't deprecate that. All right. Well, that was my one more robot-y thing. And then I have increasingly less robot-y things. So my next thing is a question, not an observation, and that is: has anyone messed with these time-lapse cameras? Maybe for construction site, maybe for plants.
Mm-mm.
Are they like surveillance camera type things?
Yeah, I've seen a couple online. I don't have the links with me. And there's some projects out there for Arduino. I was thinking maybe John G has some thoughts on this, but basically I want to put one. Okay, this is where we diverge from robots. I want to put one in my garage so I can do a time lapse of auto restoration. I just want to mount it to the garage rails.
Well, in principle, it's basically simple. I mean, you just in the most basic sense, you would set up a camera, or if you want to do it with a Raspberry Pi and a Pi camera, you could do that, and then you just make sure that the position is fixed. You know, the position doesn't change, and then at either regular intervals or at intervals of your choice, you take a photo.
Yeah. I believe there is some projects already out there for the ESP32 cam. I messed around a little bit with it, but if you wanted to go the route of using the PyCam, I believe there's a new PyCam module that might serve well for that purpose.
And that's really what I'm after, because it'd be nice to have decent qualities. So the things would be decent quality camera and image, so good low light, good resolution. And then it'd be nice if you don't have to reinvent from scratch all the software to do it scheduled or start. It'd be nice if it could go across the internet so you don't have to climb up on a ladder to push the button all the time.
Well, but here's the thing is, when you say time lapse, for the kind of project you just described, you actually probably want to select when you've made it, select the photo when you've made a specific change, right? Rather than
or let's say there's an afternoon. Let's say there's an afternoon of work, right? So you want to just push a button and then have it every 10 seconds or something that afternoon, and then shut it off when the work session's over.
Oh, so you are interested in real time lapse and not just a progression of images?
I figure there'd be other. I mean, it's a multi-camera event, I think, but I'm just wondering if anyone's got some good recommendations on off-the-shelf stuff and good cameras. And otherwise, I found this one thing on Amazon, $180. It looks like a good starter, and then maybe later on I'll fiddle with one of the high quality webcams on the Raspberry Pi 4 or something.
Right. If you do the HQ, the 12.3 megapixel, I think is what they're currently at.
Yeah.
Or, those are fairly cheap.
Or even it looks like if I understand it, so like this webcam I'm using now, this Logitech Brio it's pretty good low light. It's a really nice quality. It's 4K. But it needs like USB 3. So I thought if I was reading right, it looked like the drivers on the Pi 4 might actually support it.
And just for simple time lapse, if you say I want a photo every X number of seconds until when I start it, and then a way to stop it, you could probably do that. A Python script in 20 lines of code.
That's what I figured. Right. And then it's just a matter of remote switch to start and stop it, and a place to store it. So
now the remote switch would you need a little extra thought about that.
Well, I mean, I know how to get like I have a Pi in my office here that it's on Wi-Fi, and I've got this all set up with MQTT messaging and Bluetooth BLE switches. So I could actually take this little BLE dongle that has a switch built in, and I could make this be the start-stop. or just like VNC into it, right? So there's
Is that MQTT setup? Is that hosted on the Pi itself? Because that might be a thought. If not,
yeah. And welcome aboard, Cooper. I'm not sure if you've seen you online before. If this is your first time, welcome. But I've acquired a bunch of this Espruino based hardware, and Espruino is basically some guy in the UK has a little ecosystem. He's written from scratch with a handful of Kickstarters. And basically, he's ported some JavaScript compiler so that it runs on very effectively on like a button cell battery on a coin cell. So JavaScript is inherently or Node.js is inherently event driven. So what he does is he's mapped the library in a way that when an event wants to happen, it wakes up and runs it, and goes back to sleep. So it's really cool. It's battery efficient. And they tend to run his hardware tends to run on the NRF series of modules, which are pretty nice little processors. I mean, they got a lot of capability to them. So one of the things that he has is a BLE to long-winded answer, Cooper. So he has a BLE to MQTT gateway that runs on a Pi. So you just put a Pi on your network, and it's got a little MQTT server, and since the Pi has Bluetooth, it can just sit there and scan for BLE emissions. And when it sees a BLE emission, it can generate an MQTT event or do whatever.
Well, here's a thought that something you can do that will eliminate the need to start it and stop it. You just do the same thing I did and use the Motion app.
Right?
So until something changes in the image, it's not going to do anything. It's not going to take an image. As soon as you move or change something, then the new images will be captured. You just have to learn how to configure it to capture only at a certain rate. So for that, you don't have to write anything. You just install the Motion app, hook up the camera, and you're off to the races.
That's the thing. There's so many options out there.
I will say that that's actually, in truth, probably a little bit more difficult than writing your own Python script, because Motion comes with quite a bit of configurables, and so you'd have to toy with it with the configuration for a while before you could figure out to get the motion capture just like you want it.
And Python has a lot of very accessible HTTPS libraries, so in a sense, you could, call that MQTT network that you've already got set up, and it might not even be that difficult with a Python script. And then with Python, obviously there's Pillow that you can, do nice color balancing on the image and whatnot, post-processing, and then compiling it all into an image or a video before you ship off to wherever data center you're shipping it off to, I guess.
This laptop.
For anybody who, by the way, if anybody wants to toy with the Motion app, there's two implementations. The one you see most common is what they call Motion iOS, which is basically I think the Motion app is underlying that. I haven't looked into it, but Motion iOS is basically it's an image for your Pi, kind of like when using Octopi with your printer. You just take the whole image, and flash the SD card. The Motion app is just a motion triggered application, video image application that you install on your Debian OS. Now, if anybody is wanting to play with the Motion app, just the Motion app, and wants to learn how to configure it, I can help them out.
Cool.
Carl, are you going to I don't know, try to not show where your location is when you're doing this, because you're going to be producing something that's going to have quite a bit of worth after it's all said and done.
Yeah.
And you don't want somebody to know where it is.
Yeah. So there's definitely that, and that gets to the next non-nobody question here. But yeah, I mean, so I think it's relatively easy to control EXIF data before you publish, right? You can strip that stuff off.
Okay.
Put anything on YouTube. So.
The thing
Just don't want to
I
overshare.
is whether, every 10 seconds or so would give you what you want. In other words, be rather jerky.
Yeah.
Are you trying to do it like, play it back at a faster speed to make it look like it's real time or something? Or
Well, so the thought is that even if you go with something like this Logitech Brio, I mean, assuming that a Pi can read it in, it's a decent enough camera, but it's a camera that pales in comparison to what you can do like on a modern iPhone or some other like a DSLR. So I figure that I'll just put one thing up on the rafter there by the garage rail. It's just going to sit there for the 2 or 3 or 4 years that it takes, right? and it'll just be the overall. It'll be a long running thing, and then just gather images. And then when it comes to specific things, there's high quality cameras for that.
I was going to say, you could have a lot of frames if you're going to do it too fast,
and I didn't actually think about the post processing part. You don't just want to sequence a list of images. You want to be able to stitch them together in a video.
Yeah.
And I don't know if anybody has done that.
I have.
You have? Okay. Well, then you probably you know what you need to do there.
Yeah. There's a lot of ways to do it. I use a tool called Vegas Pro. Used to be by Sony. Now it's by some German company. But okay. Hey, well, thank you for all that feedback. I didn't want to take us too far off robots, but I'm gonna